Welcome to Brain Booster. Have you ever looked up at the night sky and pondered the origins of the universe? This question has fascinated humanity for as long as we've been able to gaze up at the stars. Our ancestors looked up in wonder, trying to make sense of what they saw. This fascination, this curiosity, has led us to unravel many mysteries of the cosmos. Today we're still asking questions, still trying to comprehend our place in the grand scheme of things. And one of the key pieces of this cosmic puzzle lies in the concept of the Big Bang. It's the leading scientific theory about the universe's origin, a cataclysmic event that created everything we see around us and much more we don't see. From the smallest particle to the grandest galaxy, everything traces back to this singular moment. So let us delve into the mystery of the Big Bang and the aftermath that shaped our cosmos. Around 13.8 billion years ago, all matter, energy, and space itself was contained in a singularity, an infinitesimally small point. Imagine that, all the vastness of the cosmos we see today, packed into a space tinier than the head of a pin. This singularity was unfathomably hot and dense, a place where the laws of physics as we know them could hardly apply. Suddenly, in a moment of cosmic drama, the singularity began to expand. This wasn't an explosion in the conventional sense, but rather an incredibly rapid stretching of space. This event, which we now call the Big Bang, set the stage for everything that would follow. In the blink of an eye, the universe went from a point of almost infinite density to an expanding bubble of energy and matter. In this early stage, the universe was a hot, dense soup of particles, too hot for any atoms to form. But as the universe expanded, it also cooled. Energy transformed into particles and antiparticles, which immediately annihilated each other upon contact. But for some unknown reason, there was a slight imbalance in favor of matter over antimatter. For every billion pairs of particles and antiparticles, there was one extra particle of matter. And it's this excess that would eventually form all the stars, galaxies, and planets we see today. The first subatomic particles to form were protons and neutrons, along with their antiparticles. These particles started to collide and combine, forming the first atomic nuclei in a process known as nucleosynthesis. This all happened within the first few minutes of the universe's existence. So from a singularity of almost incomprehensible density and heat, the universe expanded and cooled, giving rise to matter, energy, and the basic building blocks of everything we know. In mere moments, the universe had expanded from smaller than a proton to something billions of miles across. And that, my friends, is the Big Bang in a nutshell. But our journey doesn't stop here. Stay tuned as we continue to explore the aftermath of this cosmic event. Following the Big Bang, the universe was a hot, dense soup of particles and energy. Imagine a cosmic cauldron simmering with unimaginable heat and pressure, a swirling mass of chaos that was, in essence, the birth cry of our universe. As time went on, this cosmic soup began to cool and expand. Now, when we say cool, we're not talking about a nice breezy day in autumn. We're talking about temperatures dropping from trillions of degrees to just billions, still hotter than anything we can fathom, but cool by cosmic standards. This cooling period stretched over hundreds of thousands of years. As the universe cooled, the particles within it began to slow down. This slowing down allowed particles to come together, forming the first atoms. These atoms were primarily of two elements, hydrogen and helium, the simplest and lightest elements in the periodic table. But here's something to ponder. When these atoms formed, they effectively freed the photons, the particles of light that had been trapped in the dense hot soup. These photons were now free to travel across the universe, a phenomenon we can still observe today as the cosmic microwave background radiation. This release of photons marked a significant shift in the universe. The soup of particles and energy had cooled and expanded enough to become a universe of atoms and light. But this wasn't the end of the story, far from it. The universe continued to cool and expand, and as it did so, it became less opaque. It was as if a cosmic fog was lifting, revealing the universe in all its nascent glory. This transition period from an opaque universe to a transparent one is often referred to as the Cosmic Dark Ages, marking the end of the universe's first major chapter. And so, the aftermath of the Big Bang set the stage for what was to come. From a dense, hot soup of particles and energy, the universe had become a vast expanse of atoms and light. This era ended with the universe becoming transparent to light, a period we now call the Cosmic Dark Ages. Opening. As the universe continued to cool and expand, gravity began to pull matter together. It was a time of extraordinary transformation, a time when the universe's raw materials took on a new shape and purpose. Picture a colossal cosmic ballet, with gravity as the choreographer, the dancers, countless particles of hydrogen and helium, the universe's most basic elements. These particles, drawn to each other by the irresistible force of gravity, began to form into vast clouds. It was within these clouds that the first stars were born. As these clouds of hydrogen and helium collapsed under their own weight, their cores grew hotter and denser, until finally the pressure was so great that hydrogen atoms began to fuse together, creating helium in a process known as nuclear fusion. This process released an enormous amount of energy, causing the stars to shine brightly. But the life of these early stars was volatile and short-lived. Their intense heat and pressure led to the creation of heavier elements like carbon and oxygen, and when they could no longer sustain nuclear fusion, they exploded as supernovae. These cataclysmic events not only marked the death of the stars, but also the birth of something new. The explosions scattered the heavier elements across the universe, seeding it with the building blocks of planets and life. These elements, carried by the cosmic winds, found their way into new clouds of gas and dust, which would eventually coalesce to form the next generation of stars and galaxies. Over time, this cycle of birth, death, and rebirth led to the formation of increasingly complex structures. Stars clustered together to form galaxies. Galaxies grouped together to form galaxy clusters, and clusters linked up to form vast cosmic webs. Closing. The universe was no longer a simple soup of particles, but a complex tapestry of stars, galaxies, and vast cosmic structures. Fast forward to today, and the universe is a vastly different place. The cosmic scene that began as a hot, dense point has now transformed into an expansive, dynamic panorama. Our universe is home to billions of galaxies, each a bustling metropolis of billions of stars. It's like a cosmic cityscape, with each star a beacon, each galaxy a neighborhood, each cluster a city in the grand cosmos. Every star we see, every galaxy we can observe is part of this elaborate tapestry woven by the threads of cosmic time. Stars, planets, and galaxies are not just physical entities, they are timestamps, each telling a unique story of the universe's journey from the Big Bang to the present day. Now, let's talk about the universe's ongoing expansion. Edwin Hubble in the early 20th century discovered that galaxies are moving away from us. This means that the universe is getting bigger, it's expanding, and not just expanding, but the rate of this expansion is accelerating due to a mysterious force we call dark energy. This discovery has profound implications for the future of the universe. If this expansion continues unabated, we might find ourselves in a universe where galaxies outside our local group are so far away that their light never reaches us. A lonely universe indeed. But fear not, for this is billions of years in the future. For now, we continue our cosmic journey, exploring the vast expanses of the universe, seeking to understand our place within it. We are, after all, children of the cosmos, born from stardust, living on a pale blue dot in the cosmic ocean. Our story is the universe's story, and as we probe deeper into the cosmos, we come closer to understanding our cosmic roots. As we gaze upon the cosmos, we are not only looking at distant stars and galaxies, but also peering back into the very history and origin of the universe itself. So what have we learned about the Big Bang and its aftermath? Well, we've journeyed from the very beginning, where the entire universe was condensed into a point of infinite density and temperature, to the momentous explosion that set everything in motion. The Big Bang, as we call it, was not just an explosion, but an expansion of space itself. In the immediate aftermath, the universe was a hot, dense soup of particles. As it expanded and cooled, these particles came together to form the first atoms, mainly hydrogen and helium. Over hundreds of millions of years, these atoms clustered together under gravity to form stars and galaxies, turning the universe into the star-studded expanse we see today. The universe continues to expand and evolve, but its origins can be traced back to that single monumental event. The story of the universe is a grand one, full of mystery, wonder, and a big bang that started it all. Thanks for watching. Don't forget to like and subscribe.